More grease is not automatically better. When a bearing cavity is overfilled, the rolling elements churn the grease. Friction and temperature can rise.
Good fan maintenance begins with the exact bearing and lubricant instructions, not a universal number of grease gun strokes. Before shutdown, capture a repeatable operating fingerprint: fan speed, vibration, bearing temperature, motor current, airflow or pressure, and abnormal sound.
Record the system condition too. A measurement without speed and duty context is hard to compare later. Now identify the exact asset, model and serial number, duty point, direct or belt drive, bearing designation, lubricant specification, operating hours, and environment.
The machine drawing, bearing label, and motor manual control the procedure.
A generic fan checklist cannot replace them. Maintenance can expose personnel to unexpected startup, stored electrical energy, hot surfaces, or windmilling. Authorized personnel follow the site energy control procedure: prepare, shut down, isolate every source, apply lockout or tagout as required, control stored energy, and verify isolation before access. First, distinguish sealed or lubricated for life bearings from relubricatable bearings. A sealed bearing may have no approved relubrication path. Do not invent one with spray lubricant. If the bearing is relubricatable, locate the exact fitting, relief or drain arrangement, and the applicable instructions. Relubrication has 3 settings: grease type, quantity, and interval. All 3 depend on the exact bearing and application. Speed, load, temperature, shaft orientation, vibration, moisture, dust, and operating hours can change the interval. Clean the fitting and confirm grease compatibility before adding anything. 3 mistakes repeatedly create trouble: forcing contamination through a dirty fitting, mixing incompatible grease bases, and overfilling the housing. A hotter bearing after service is not proof that it needed still more grease. Stop, compare the trend, and follow the product procedure. Inspect the inlet, impeller, housing, guards, filters, and drains. Use an approved cleaning method and protect the motor and electronics. Remove buildup without bending blades or moving balance weights. Moisture, corrosion, erosion, cracks, rub marks, or loose material require escalation, not cosmetic cleaning alone. Inspect the hub, shaft, fasteners, foundation, isolators, belts, sheaves, couplings, and guards that apply to this fan. Look for looseness, corrosion, misalignment, wear, and damaged protection. Belt tension and coupling alignment come from the exact drive data. There is no universal thumb pressure setting. Clear tools and debris. Check wheel clearance and evidence of rubbing. Rotate the assembly by hand only when the approved procedure permits and all energy hazards are controlled. Confirm service doors, guards, and fasteners are ready for restoration before removing controls. Restore the machine under the site procedure, notify affected personnel, and start with guards in place. Confirm rotation, then compare vibration, bearing temperature, motor current, airflow or pressure, and sound at the same speed in system condition. Stop if the response is abnormal. Log what changed and choose the next action: return to service, shorten the interval, inspect or repair, or replace a component. For a maintenance-ready fan package, send Longwell the exact model, drive type, bearing label, duty point, operating hours, and baseline trends.